Alright, this section talks about optimization problems or applications of minima and maxima, which is the same idea. So we're trying to maximize or minimize certain values, and that's where you have to start. Find two numbers whose sum is 50. Let's say the numbers are x and y, and whose product is a maximum. So that's really what you have to maximize. The product of the two numbers is x, y. This product is a maximum, and we want to find the maximum. You take a derivative and you set it equal to 0. The only issue is this parameter is in terms of, this product is in terms of two variables, and since this is a system of equations, that's when you need to decide whether you want to get rid of x or y, and it doesn't matter. So if you solve for y, that will be 50 minus x, and you would substitute because this is a system. So the product now looks like x times 50 minus x. The product is negative x squared plus 50x. And if I want to maximize a value or minimize it, I take its derivative and I do my testing to confirm. And I set that equal to 0 where it's undefined. That's when x equal negative 20. That's when x equal 25. So if I do my testing, there's x equal 25. There is the rate of change of the product. There's the product. I point to the left, say 1. That will be positive. I point to the right, say 100. That will be negative. So we have a maximum product when x equal 25 and y would be 25. And there it is. Here's a second problem. So again, you gotta just adjust to what they're asking and come up with the equation. Find the dimensions of a rectangle. We have one of these rectangles. The area is 100 square inches. Whose parameter is as small as possible. Parameter is twice L plus twice W, and area is length times width. Again, parameter is as small as possible. We're trying to find the minimum of parameter, and parameter depends on two unknowns. So again, we solve for length or width, and it doesn't matter. If you solve for the length, that will be 100 over the width, and we use substitution. Then my parameter becomes 2 times 100 over W plus 2W. So the parameter is 200 over W plus 2W. And if I take a derivative, that will be negative 200 over W squared plus 2. So that will be negative 200 plus 2W squared over W squared. So if I do my testing like I did before, where does P prime equal 0? Where does P prime not exist? Well, that's when W equals 0. And if I set that equal to 0, I'll be looking at 2W squared equal 200. So W squared equal 100. And if I square root both sides, W will be plus or minus 10. Well, length cannot be negative. So, and 0 is useless. Of course, if you want the smallest parameter, let the width be 0 and the length will be 0 and don't make it at all. So, if I pick a point between 0 and 1, 10 say 1, put 1 in there. The denominator is always positive. Negative 200 plus 2 is negative for sure. A point to the right of 10, say 11. 121 times 2, that's 200 and some, minus 200 is positive. So we have a minimum perimeter when the width equal 10 and the length equal, if I put a 10 right there, 100 divided by 10 will be 10. Or you could simply say 10 by 10. That'll work. That will be the smallest possible perimeter, basically a square. A box with its base length twice the width. Its length is twice the, so if the width is x, the length is twice that width. And no top. Must have a volume of 1,000 cubic centimeters. Find the dimension of the box with the least amount of material. Amount of material is the surface area. Well, the surface area will be the area of the base, that is 2x times x, that's 2x squared. And since it's an open top, no top, I'm not going to count the top. This side is x by h, and there's two of them. And this front side is 2x by h. So 2x by h, and there's two of them. There's a front and there's that back. So the surface area is 2x squared plus 2xh plus 4xh is 6xh. And you notice again, that's going to always be the case. There are two unknowns, and that's where volume comes in. Isn't volume length times width times height? So x times 2x, that's 2x squared, times h is 2x squared h, and if I solve for h, that will be 1,000 divided by 2x squared. And my equation would become so 2 divides 1,500 times. So S would be 2x squared plus 3,000 over x. If I take a derivative of that, that is 4x minus 3,000 divided by x squared. By the way, I'm getting that from saying, moving this up, bring the power down, subtracting the power. Since I do that so many times, it becomes evident. So S prime is actually 4x cubed minus 3,000 divided by x squared. And where is S prime equals 0? Where is S prime not exist? It doesn't exist if x equals 0. It equals to 0 when x cubed is 3,000 over 4 divided by 2, that's 1,500, that's 750. And x will equal the cube root of 750. On a number line, cube root of 750, that's what x is. There is S prime, the rate of change of the material, the surface area, and there is S. If I pick a point to the left, say 1, 4 times 1, that's 4 minus 3,000 over 1, that's negative. A point to the right of the cube root of 750, well, the cube root of 1,000, which is 10. If I put that in there, that will be 4,000 minus 3,000, which is positive. So we have minimum surface area. And again, you could give dimensions if you want. So you could say when we have, find the dimensions. Normally that's how it is. So we could say x is the cube root of 750, centimeters, by 2 times that, twice the cube root of 750 times. And if we look at, where was it? The height was right there. And 500 divided by the cube root of 750. I know that doesn't look very pleasant, but you could leave your answer like that. There's nothing wrong with that. Okay, next problem up. A box with a squared base. What does that mean? That means the length equal the width in this case. We call this H. A box with a square base and an open top. Again, it's an open top. Is to have a volume. The volume is 24 square feet. Wait. There we go. Better. And isn't volume length times width times height? There's my first equation. Material of the base costs $5 per square feet. Material for the sides costs $8 per square feet. Find the cost of the material for the cheapest container. Well, let's see. The cost function is going to be, and let's see. We have a base and it's open again. So $5 times the area of the base plus the side is XH. But there's 1, 2, the front and the back, 4 of them. And each of those is going to cost 8. The cost is 5x squared plus 32xh. We are trying to minimize the cost. Well, too many unknowns. If we solve for h, that's 24 divided by x squared. Substitute that in there. Then the cost would be, oh, let me see the previous problem. Was it squared? It was squared. So you square that. There. My mistake. Alright, so the cost here is 5x squared plus 32x times 24 over x squared. The cost is 5x squared plus, and if I multiply 32 times 24, $768. And now you know the drill. Take a derivative. That would be 10x minus 768 divided by x squared. So where does the derivative equal 0? Where does the derivative not exist? Doesn't exist when x equals 0. And that's when x equal 76.8 over 10 cube root. That reduces, of course. Now you have a scientific calculator. You could use that. When I do my testing, I'm going to do the cube root of, let's say, 76.8. A point to the left, say 1. 10 minus 768 is negative. A point to the right, say cube root of 1000, which is 10. That's going to definitely be positive. So we have a minimum cost when what? When x is at the cube root of 76.8 by the cube root of 76.8 by so that's the length, that's the width, it's the same. And if I plug it in, 24 divided by the cube root of 7, of course you could plug that in your calculator and get an answer, and that was in feet. That would give the minimum cost. Show that of all rectangles with a given area, if they gave me the area, so to say the area is 10 or 20 or 30, given area, so A is given, it's an actual number. And I know that area is length times width. The rectangle with the smallest perimeter is twice L plus twice W, is a square. Well, suppose A is not given, but suppose A is a constant. Then if I solve for W, that would be A, that number over L, substitute that, and we're going to need that later on. Then the perimeter is going to be twice L plus 2 times A over, remember, A is a constant. And if I take a derivative, that's 2 minus 2A, which is a constant, over L squared. That is 2L squared minus 2A. Where does P prime equal 0? Where does P prime not exist? Well, that's when L equals 0. If you set that equal to 0, L equal the square root of A. Let's do the testing. If L equal the square root of A, to the left, I'm going to take the square root of A over 2 as a test point. And if I substitute that in there, that's always positive. You square that, you're going to get, I should have said there, you're going to get A over 2. The 2's cancel out. So A minus 2A is negative A. Since A is an area, that's negative. A point to the right of that, I'm going to say the square root of 2A. You could always do that. So if this is the square root of 7, square root of 7 over 2, square root of 14. If you plug that in, you square it, that's going to be 2A times 2, that's 4A. 4A minus 2A is 2A, and A is area, so that's positive. So we have a minimum perimeter when L equal radical A and W equal, if I put radical A right there, A divided by radical A is also radical A. And if the length and the width are equal, isn't that a square? One more problem. A rectangular area is adjacent to a building. It's to be enclosed by a fence on the other three. So you're going to enclose the area on 3 sides. The building part, you really don't have to enclose. If the area is 20 square feet, and if no fencing is needed along the building, what dimensions requires the least amount of fencing? The perimeter is, if you call this L, this is L, this is W. So the perimeter is 2L plus W. Again, these are two unknowns. Area is length times width. So if I get rid of W, that's 20 over L. Substitute that right there. And the perimeter is twice L plus 20 divided by L. So, if I take a derivative, that's 2 minus 20 over L. The derivative is 2L minus 20 over L. Where does P prime equal 0? Where does P prime not exist? Well, that's when L equals 0. And this is when L equals 10. If I pick a point to the right, left of 10, say 1, put that in there. 2 minus 19, 2 minus 20 is negative. Point to the right of 10, say 11. 2 minus 20 is positive. We have a minimum perimeter. And again, they want the dimensions. At the length, we said is 10. And if you put a 10 in there, isn't that a 10? And that would be in feet. Length equal the width, which is 10 in this case. So it's also a square. And that's pretty much it for this video.